Hi friends, our goal today is to be able to solve and graph inequalities. So we talked a little bit about inequalities yesterday, what they are and what they look like on a number line. And so what we're going to work on now is solving them and graphing them on the graphing those solutions on a number line. We're going to do 3 examples, and if you would like to take notes, that would probably be a good idea. And feel free to watch this video more than one time, and feel free to pause it as well if you're taking notes. So for our first example here, here's our inequality, and as you can see, it looks similar to an equation, but instead of an equal sign, there's a less than or equal to sign. So just like when I solve an equation though, I'm going to draw a line at that inequality symbol, and I see parentheses here, so I'm going to do the distributive property. Another way to do it would be to subtract 2 from both sides and then divide by 6, but I just really feel comfortable with the distributive property, so I'm going to go ahead and do that. When I do 6 times negative 4, I end up with negative 24, and 6 times negative 8x is negative 48x. And then I still have my plus 2. That wasn't involved in the distributing at all because it's outside those parentheses. So that's still there. And I still have my less than or equal to sign, and I still have my 218. All right? Now I see some like terms I can combine over here. I see this negative 24 and this positive 2, and when I combine those, I get negative 22. So I combine those like terms, and then I still have my negative 48x, and then I still have my less than or equal to, and I still have my 218. Oops, I forgot the x with my 48. Alright, now I'm going to try to isolate this variable or get the variable by itself. I'm going to get rid of this negative 22 first by adding it to both sides so that it will cancel out. So we're going to add 22 to both sides. These 22s are gone. That's helpful because now all I have here on the left is negative 48x. I still have my less than or equal to, and then 218 plus 22 is 240. All right, I just have one step left, a one-step equation, and so to get rid of this negative 48 to isolate the variable, I'm going to divide both sides by negative 48. All right, that is very helpful because now these negative 48s are gone. I have x on the left, and I have negative 5 on the right. Something very important happens though. This is really important. When you divide or multiply both sides by a negative number when you're solving inequalities, something happens to the inequality symbol, and that is that it flips, so it'll face the opposite way. So instead of x is less than or equal to negative 5, it's going to be x is greater than or equal to negative 5. And that is because we divided by a negative number. That's also true if you multiply by a negative number. All right, so let's go ahead and graph this on a number line. I'm just going to put negative 5 here because I know that's my solution. Put negative 6 over here. We'll put negative 4 over here. I'm going to use a closed circle because this represents my solution, and it can include negative 5 because of this underline here. So when it's underlined, we're going to use a filled-in circle to show that the solution includes negative 5. And this says x is greater than or equal to negative 5. That's because the alligator is eating the x, and the alligator always wants to eat the greater quantity. So x is greater than or equal to negative 5, so I'm going to make the arrow point toward the greater numbers on the number line. And there's my solution. All right, let's try another one. Feel free to pause this video or go back and watch it again if it seems like it's fast. All right, so our second example, this inequality says x over 4 is less than negative 3. So remember, the goal is always to try to get x by itself, but I have this 4 down here on the bottom, so I want to make that cancel out. The way we're going to do that is to multiply both sides by 4. See, this 4 is at the bottom of a division problem, right? When something is something over something else, that's like x divided by 4. So if we do the opposite and multiply both sides by 4, whatever we do to one side, we have to do to the other. These 4's now cancel out because we multiplied by 4. So we have x on the left, and then we have our less than sign, and then we have negative 3 times 4, which is negative 12. Notice I did not flip the inequality sign. So I kept this inequality sign as less than, That's because I wasn't multiplying by a negative number. I multiplied by positive 4. Even though this 3 over here was negative, since the number I was multiplying by was positive, I did not flip the inequality symbol. So let's go ahead and graph it. I'm going to put negative 12 here on my number line, and negative 13 here, negative 11 over here. And this time, I'm going to use an open circle. This solution says x is less than negative 12. That means negative 12 is not included in the solutions. X cannot equal negative 12. So I'm going to use an open circle to show that, and then I'm going to make my arrow point toward all the numbers that are less than negative 12. So the arrow points that way. All right, let's try one more just to be sure we're 100% clear on how to do this. Okay, so our example number 3 here, we have 7 times the quantity x minus 7 minus 3x is less than negative 81. Just like when I'm solving equations, I'm going to draw a line at the symbol here. It's not an equal sign, but at the less than symbol to split the equation into 2 halves. I see parentheses here again, so I'm going to go ahead and distribute. 7 times x is 7x. 7 times negative 7 is negative 49. And then we still have our negative 3x over here, which wasn't involved in the distributing at all, but it's still there. And then we have less than, and then we have negative 81. All right, I see some like terms again that I can combine. 7x and negative 3x. 7 minus 3 is 4, so we have 4x. We still have our minus 49. Oops, that's not a 9. Still have our minus 49, and we still have our less than, and we still have our negative 81. All right, now we're going to try to isolate this variable, try to get the x by itself. So I'm going to add 49 to both sides. That's going to help us out because the 49s on the left side will cancel out. So now all we have here on the left is 4x. Lovely. And we still have our less than. Negative 81 plus 49. Let me see. I'm going to do some quick calculations here. Let's see. My calculator is it's not really cooperating with me right now. I don't know what it's doing actually. Let me get a different calculator. All right, it looks like that equals negative 32. All right, one more step left. We're trying to isolate the x. So I'm going to divide both sides by 4. And notice this is a positive 4. So do you think I should flip my symbol to be a greater than instead of less than? Hopefully you said no, because we don't want to flip our symbol because we're dividing by a positive number. Even though the 32 is negative, the number that we're dividing by is not. And negative 32 divided by 4 is negative 8. So our final solution set is x is less than negative 8. So that means our solution could be anything less than negative 8. It cannot equal negative 8 though, because the symbol is not underlined. So I'm going to put negative 8 here, which means we know we'll have negative 9 over here, negative 7 over here. I'm going to use an open circle because negative 8 is not included in our solution, and then I'm going to make my arrow point toward all the numbers that are less than negative 8. Hopefully that those 3 examples brought back memories from last year and helped clear things up. If you need help on anything today, any assignments, please email me. And if you need to rewatch this video, feel free to go back, rewatch it, take notes, pause it, whatever you need to do. I hope you have a great rest of your day.